Welcome to the Science of Large Language Models, the podcast where we explore the latest research and advancements in the field of language models. In today's episode, we will be discussing a research paper titled Textbooks Are All You Need, which investigates the use of high-quality data to improve the performance of large language models for code generation. The researchers behind this paper aimed to address the question of whether high-quality data can enhance the capabilities of large language models trained for code generation. They proposed a new model called Phi-1, which is based on the transformer architecture and consists of 1.3 billion parameters. The training process involved two main phases, pre-training and fine-tuning. During pre-training, the researchers utilized a combination of textbook quality data. This included a filtered code language dataset obtained from the Stack and Stack Overflow, as well as synthetic Python textbooks and exercises generated using GPT 3.5. The total size of the pre-training dataset was less than 7 billion tokens. The Phi-1 model was trained on the code textbook dataset during the pre-training phase. The training process utilized deep speed on 8 NVIDIA A100 GPUs and lasted approximately 4 days. The researchers employed specific hyperparameters, such as a maximum learning rate of 1E3 and a warm-up period of 750 steps. In the fine-tuning phase, the researchers used a smaller synthetic exercises dataset called code exercises, which aimed to align the model's performance with function completion tasks based on natural language instructions. Fine-tuning was performed on the Phi-1 base model using the same training setup as pre-training, but with different hyperparameters. The model was trained for 6,000 steps and the best checkpoint was selected for evaluation. To evaluate the performance of the Phi-1 model, the researchers used two benchmark datasets, Human Evil and MBPP, mostly basic Python programs. The pass-at-1 accuracy scores on these benchmarks were reported, with Phi-1 achieving 50.6% on Human Evil and 55.5% on MBPP. These results demonstrate the model's competitive performance compared to existing approaches. The paper also highlights the emergent properties of the Phi-1 model compared to Phi-1 base and Phi-1 small models. The researchers observed surprising capabilities and understanding of complex algorithmic tasks in Phi-1, which were not explicitly present in the fine-tuning dataset. This suggests that the number of parameters plays a significant role in the emergence of these properties. One of the key benefits of this research is the demonstration that high-quality data can significantly improve the performance of language models for code generation. By curating a dataset consisting of filtered code language corpus, synthetic Python textbooks, and exercises, the researchers achieved impressive results with the Phi-1 model, despite its smaller size compared to competing models. However, there are some limitations to consider. The use of synthetic datasets, although curated to be of high quality, raises concerns about the representativeness and generalizability of the data. The biases, limitations, or errors of the AI model used to generate the synthetic data could potentially impact the model's performance and the validity of the reported results. Additionally, the evaluation metrics used in the paper, pass-at-1 accuracy on Human Evil and MBPP, may not capture the full range of the model's performance and capabilities. A more comprehensive evaluation that includes various code generation tasks and assesses aspects such as code correctness, efficiency, and readability would provide a more thorough understanding of the model's capabilities. Furthermore, the paper lacks a detailed comparison with other state-of-the-art models. Without this comparison, it is challenging to assess the true superiority of the Phi-1 model over existing approaches. In conclusion, the findings presented in the paper highlight the benefits of using high-quality data to train language models for code generation. The Phi-1 model demonstrates competitive performance despite its smaller size. However, the use of synthetic datasets, limited evaluation metrics, lack of detailed comparisons, and unclear analysis of emergent properties warrant further investigation and scrutiny. As the field of large language models continues to advance, it is crucial to address these limitations and strive for more comprehensive and robust approaches. Thank you for joining us on this episode of The Science of Large Language Models. Stay tuned for more exciting discussions on the latest research in the field.